Let's take a look at an exponential function together. Now real quick before we get started, if you'd like to download a free copy of this blank PDF or the answer key PDF, you can find a link to that in the description box below. Alright, let's get started. Here's the function that we're working with here. We have f of x is equal to negative 2 raised to the negative 2x plus 1 power minus 1. There's a lot going on here, so let's identify the parent function first. Ignoring all the transformations that are being made to this exponential function, the parent function here is going to be f of x is equal to 2 to the x power. So this right here is the parent function, and a bunch of different transformations have been applied to it to get the function that we're dealing with. Let's take a look at a formula that can help us out with these transformations. This formula right here can help us figure out what are all the different transformations that are being made on this exponential function. And again, this is the function that we are working with, so let's go ahead and just focus in on these two for a moment. While some of these transformations are going to be a little bit easier to identify than others, I'm going to go ahead and try to make this function that we're given match this formula a little bit more accurately. So going ahead and rewriting our function, we're going to get this version of the function right here. Alright, so first of all, if we take a look at this a right over here, that's going to be negative 1. So I'm going to go ahead and write that a is equal to negative 1. Then if we take a look at this positive c that's in the formula, that's going to be the same thing as adding a negative 1 or just subtracting 1. So we can say that c is equal to negative 1 as well. Moving on to k is going to be this number in front of the parentheses. So if we factored out that negative 2, we can see that k is equal to negative 2. Next, you can see the formula has this minus d, so whatever is after the minus sign is what d is equal to. So d in our case is going to equal 1/2, so we can say that d is equal to 1/2. Now don't worry about this x and this f of x because they're going to be in all of our exponential functions. And then last but not least, we have this base of b, which in this case we have 2 here. So let's go ahead and write that down and say b is equal to 2 for this particular function. Now that we've identified each of these variables and their values, let's see what kind of effect they have on our exponential function here. First up, let's see if we have a horizontal stretch or shrink. In this case, we do have one. Now in this particular case, we're going to have a horizontal shrink, or you can call this a compression, by a factor of 1 over whatever k is, and in this case k is equal to negative 2. So we take the absolute value of that because that negative has a different effect that's going to be talking about reflections in a moment. So I'm just going to say this is going to be 1 over that 2 value. So yes, we're going to have a horizontal stretch by a factor of 1/2. Now what about a horizontal reflection? For this problem, we're going to go ahead and say yes, and it's because our k value happens to be negative here. If k was positive, we're not going to have a horizontal reflection, but since k is equal to this negative 2, we know we will reflect this graph across the y-axis. What about a horizontal translation? Since d is equal to positive 1/2, we know that we will have a horizontal translation here. Because it's positive, we're going to be moving 1/2 unit to the right. So let's go ahead and say yes to this horizontal translation. Now let's move on to some vertical aspects. Now does this function have a vertical stretch or shrink? In this case, we're going to go ahead and say no, and it comes down to the fact that the value of a is equal to 1, or the absolute value of a is equal to 1. So that negative in front of a has a different effect, that's going to be a reflection, but since we know that a is equal to negative 1 here, we know that there's not going to be a vertical stretch or shrink. What about a vertical reflection? Well again, since a is a negative value here, then we know that we're going to go ahead and say yes. And that's just because whenever a is equal to a negative number, it's going to flip this entire function over the x-axis. Finally, let's see if we have a vertical translation. In this case, we're going to go ahead and say yes because the value of c is not equal to 0. So notice that we have a c value, it's equal to negative 1. So since c is equal to negative 1, we know this whole function is going to be moving down 1 unit, also known as a vertical translation. Alright, now that we took care of all the transformations, let's see what else we can figure out about this function. Starting with the asymptote, you want to remember that our exponential functions typically have a horizontal asymptote at y is equal to 0, but since we had a vertical translation of down 1 unit, our new horizontal asymptote is going to be at y equals negative 1. For the y-intercept, this always occurs when x is equal to 0, so let's go ahead and substitute in 0 into our function and see what our y value is going to be. So again, this is our original function, and subbing in 0 in for x, we're going to get this right here. Negative 2 times 0 is 0 plus 1 is going to equal 1. So this is going to be negative 2 raised to the first power minus 1. Then 2 to the first power is just 2, but the opposite of that is going to be negative 2. Take away 1 is going to be negative 3. So for our y-intercept, we know that if x was equal to 0, then y is going to be equal to negative 3. That's our y-intercept. For the domain, we're dealing with an exponential function here, so that's going to be all real numbers, or spanning from negative infinity to positive infinity, and just make sure we use parentheses when we're dealing with infinity for interval notation. Alright, now for the range of exponential functions, typically it has a floor where the horizontal asymptote is, but because we have a vertical reflection, it's actually going to have a ceiling. So for this particular function, as x approaches negative infinity, f of x or the y value is also going to approach negative infinity, but as x approaches positive infinity, or as this function moves towards the right, it's actually going to get closer and closer to that horizontal asymptote, which we know is going to be at y equals negative 1. So let's go ahead and put parentheses there, and it's not going to touch it because it's an asymptote. Now for the end behavior, this will hopefully make more sense once we sketch this function, but as x is going to approach negative infinity, f of x or the y values are also going to be approaching this negative infinity. And as x is going to approach positive infinity or go to the right forever, this function is going to be approaching this value of negative 1. So that's a lot of information about this exponential function. Now let's go ahead and see how we can graph this. The two pieces of information that we can take from here that we can put right on our graph are going to be the asymptote and the y-intercept. So let's go ahead and just start with that. All right, so for our asymptote, let's see here. We're going to go ahead and start with negative 1, or y is equal to negative 1. That's this imaginary line right here. And we know we have a y-intercept of 0, negative 3, so that's below our asymptote. That's right there. Now let's go ahead and see if we can get some more points to make an accurate sketch of this exponential function. I'm going to use this first table for the parent function, which we again remember is f of x is equal to 2 to the x power. And here's some x values that I chose. You definitely don't need to do this many, but hopefully this will help you make more sense of what we're doing. Now starting off with the easier ones here, if x is 0, then we can see 2 to the 0th power, that's just going to equal 1. Then if we say we have x is equal to 1, 2 to the first power is just going to equal 2. And because it's an exponential function, the pattern is that we're going to keep multiplying by 2, because that's what our base is, so we're going to keep doubling. Now if we go the other way here, we're going to take half each time, so half of 1 is going to be 1/2, then half of a half is going to be a quarter, and half of a quarter is going to be an eighth. So that's going to be our table for the parent function. Now what about the given function, or the function that we're dealing with? Remember this equation right over here, and try to remember this formula that we had from the beginning. Remember that a is equal to negative 1, c is equal to negative 1, k is equal to negative 2, and that d is equal to positive 1/2. We can go ahead and use each of these four variables to make a mapping diagram to make our lives a little bit easier. Whenever we're transforming any of these exponential functions, we can take each of our x coordinates and rewrite them as x divided by k plus d, since k and d affect the horizontal movement of this function, and then y coordinates can be rewritten as a times y plus c, since a and c will affect the y coordinates of this function. So basically, let's take each of these x values, and then first we're going to divide them by this negative 2, because that's what the k value is. Then after, let's go ahead and add on this 1/2. So we're going to do that for each of these now. So taking this negative 3, if we take that negative 3 and divide it by negative 2, that's going to equal positive 1.5. Then if we go ahead and add 1/2 to this, 1.5 plus 1/2, that's equal to 2. So our new x coordinate is going to be 2. So that's going to be right here. Now for our y values, we're going to go ahead and multiply each of these by negative 1, which is our a value, and then we're going to add on c afterwards. Now c is going to be negative 1, so we're going to be adding a negative 1 onto each of these values. So if we take this 1/8 here and then we multiply it by negative 1, that's going to equal negative 1/8. But then afterwards, if we go ahead and add negative 1 to this, so negative 1/8 plus a negative 1, that's going to equal negative 1 and 1/8. So that's going to be our new y value, or where it's going to move to. So it's going to be negative 1 and 1/8. So what we just did was we found out that this point that would be originally on the parent function would now be located over here on the function that we have once all the transformations have been applied. Now let's look and see when x is equal to negative 2. Let's go ahead and divide it by k, then add d, or what we said right down here. So if we take this negative 2 and we divide it by our k value of -2. -2 divided by -2 is going to be +1. Then if we go ahead and add on 1/2 to that, that's going to equal this 1.5. So this new x value is going to be 1.5. Now for this 1/4, let's go ahead and multiply it by a, then add c, also known as multiplying it by -1 and adding -1. So if we take this 1/4 and we multiply it by -1, that's going to equal -1/4. Then if we go ahead and add -1 to this, that's going to be -1 and 1/4. So that's going to be this new y coordinate, -1 and 1/4. Next, if we go ahead and take this -1 and we apply these same transformations, divide it by -2, then add 1. This -1, if we divide by this -2, that's going to be +1/2. And if we add 1/2 to that, that's going to equal +1. So this new x coordinate is going to be +1. Then if we take this 1/2 here and multiply it by a, then add c, or multiply it by -1, then add -1, let's take this 1/2, multiply it by -1, that's going to be -1/2. Then if we go ahead and take that and add -1 to it, we're going to get -1 and 1/2. So that's going to be the new y coordinate. It's going to be -1 and 1/2. Now, if you wanted to try some of these on your own now, go ahead and pause the video and try these next 4 on your own. I'm going to go ahead and fill them in just a moment. This point of 0, 1 should be transformed into +1/2, -2. This original point of 1, 2 should then be transformed into 0, -3. This 2, 4 should be transformed into this -1/2, -5. And this original point of 3, 8 should be transformed into this point of -1, -9. So again, you can just take each of these values in the parent function and then perform these transformations on them, and you'll get each of the new x and y coordinates for our given function. Now, if we just go ahead and plot a few, notice our y-intercept is correct right here on the y-axis, so that's good. Then a couple easy ones that we can plot here are going to be 1/2, -2, so that's going to be right about here. 1, -1.5 is going to be right about here. -0.5, -5 is going to be right down over here. And I'm just going to put one more on here. This +1.5, -1.25 would be just about here. Then let's just go ahead and try and draw a smooth curve through these points. And this right here would be a pretty accurate sketch for our exponential function. Now, a couple key things to take note here is that as x goes to -infinity, or as we move to the left here, notice f of x is going towards this -infinity, or it's going down forever. And as x is going to +infinity, or as we move towards the right here, this function is getting closer and closer to a y value of -1. It's never actually going to touch it though, because that asymptote is kind of like a ceiling for this function, as opposed to the parent function where it would be the floor, or underneath the function. And as for the domain and range here, notice we said from -infinity to +infinity, as well as -infinity to -1. So for the domain here, we can see here that this will move to the left forever as we move in this direction, and it will move to the right forever, so that takes care of the domain. As for the range, it does go down forever, right? But it won't go up forever. It's going to get higher and higher and higher up until -1 without touching it. And that wraps up this pretty extensive example on how to graph an exponential function when you have a bunch of different transformations applied to it. If you found the video helpful in any way, please consider giving it a thumbs up and sharing with a classmate or friend or even a teacher who might find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.